All right, so today we're going to be talking about solving radical equations. So the key when we're talking about solving radical equations is understanding opposite operations. So the opposite operation of a square root is the square of an item. So when we're starting on these process, what we want to do is we want to isolate our radical. Okay, so we have to understand what we're solving for, what variable we're solving for, and then if it's inside of a radical, isolating that radical by itself. Okay? So our first problem over here, I have the square root of x plus 7 equals 16. So the first thing I have to do is isolate my radical there. So I'm going to start by subtracting 7 from both sides. So I end up with the square root of x equals 9. Now, once I have the square root by itself, I can get rid of that square root by squaring both sides. So I'm going to come in here, I'm going to square both sides. I get x equals 81. Now, if I want to check this to make sure that answer works, I want to take this 81, plug it back in. Square root of 81 plus 7 equals 16, square root of 81. Remember, we're only looking at the principal side when we're doing these. We're not looking at the idea that it's plus or minus. We're only looking at the principal side or that positive side. So this becomes 9 plus 7 equals the square root of 6 equals 16. It checks out. Okay. Now on the second one, this is a story problem. I'll kind of read the story problem to you. It's example 2 on page 634. The time t in seconds it takes a pendulum of a clock to complete a full swing is approximated by the equation t equals 2 times the square root of L over 3.3, where L is the length of the pendulum in feet. If the pendulum of a clock completes its swing in 3 seconds, what is the length of the pendulum? Round to the nearest tenth. So it gave me how much time it was. So 3 equals 2 square roots of L over 3.3. So I'm trying to solve for L in this example. So the first thing I'm going to do is I got to get rid of this 2 here. So what I'm going to do is I'm going to divide by 2, divide by 2. So 3 divided by 2 is 1.5 equals the square root of L over 3.3. Now I have the square root isolated. So what I'm going to do is I'm going to square both sides. So I'm squaring both sides. This gives me 2.25 equals L over 3.3. Now the 3.3 is dividing L. So what I want to do is I want to make sure that I multiply both sides by 3.3. Okay? So L is now 7.425. Okay. And it asks us to round to the nearest tenth, so 7.4 feet. So there's my length of my pendulum. Okay. So our third example is one in which I have a radical on both sides. I don't have any other numbers, I just have a radical. So since these radicals are equal to each other, I actually can just kind of square both sides. And you notice that what happens here is my square roots end up going away. And so now I have 5t minus 11 equals t plus 5. So what I'm trying to do now is I'm going to solve this just like I did at the beginning of the year. I'm going to bring over my t here so that I have the t's on the same side. So 4t minus 11 equals 5. I'm going to add my 11 over. 4t equals 16, and I'm going to divide by 4. T equals 4. Now I should really check this answer to make sure that I don't get what they call an extraneous solution. An extraneous solution is where we solve it out. It looks like this is the answer, but when we plug it back in, we get something that can't happen. So if I plug it back in, I have the square root of 5 times 4 minus 11 equals the square root of 4 plus 5 So this gives me 20 minus 11, which is 9, equals the square root of 9. And the square root of 9 equals the square root of 9, so that's the answer, so it checks out. Now we have a problem here where I have a variable that's not inside my square root. So I have some items that aren't inside my square root. So I'm going to go ahead and I'm going to square both sides here. I've already isolated my radical, and so now I have n squared equals n plus 12. Now, if you recall, a couple chapters ago, we talked about quadratics and solving quadratics. We can either solve them through factoring, completing the square, quadratic formula. So to start that process, what I'm going to do is I'm going to move everything to one side. So I'm going to subtract off my n and my 12 over here, so I get n squared minus n minus 12 equals 0. Now, I'm going to show you the factoring side of it. Any of the others work, the quadratic formula works. It's just that this one's nice in factors. So I'm going to look at the factors of 12 that subtract to give me negative 1. Well, the factors of 12 that subtract to give me negative 1 are negative 4 and positive 3. Now we have to look at what makes this 0. So I'm going to set each of these equal to 0 and solve. So this gives me n equals 4, and this gives me n equals negative 3. Now I ended up with two answers. I might have two answers that actually satisfy this, but I have to test them. So I'm going to start by testing 4. 4 equals the square root of 4 plus 12. 4 equals the square root of 16, or 4 equals 4. That actually works out, so I know 4 is one of my answers. So now I'm going to plug in negative 3. Negative 3 equals the square root of negative 3 plus 12. Well, the problem here is I end up with negative 3 equals the square root of 9. Remember that we were only talking about the principal side, or the positive side. So when I take the square root of 9, I'm supposed to get positive 3. This one does not work, so this is an extraneous solution. Okay? Remember that I always want the square root when I'm solving these to be equal to a positive side. So if I end up with an equation where I would get a negative, there would be no solution. So let me give you an example of that. So let's say I have the square root of 3y plus 8 equals 2. So right when I get here, so once I subtract 8 and subtract 8, I get the square root of 3y equals negative 6. And here, when we solve this out, we are going to get an answer, but we're going to find that answer is extraneous. Right here, I notice that I'm going to have a problem because I have to take the negative side of the square root. But we're going to continue to solve it out and then plug it back in, so that way we can show you that you get that extraneous solution. So this gives me 3y equals 36. When I square negative 6, I get 36. Divide by 3, y equals 12. Now when I plug this in here, so I get the square root of 3 times 12 plus 8 equals 2. Well, this gives me 36. And we were talking about we only want to take the principal side or the positive side. So when I take the square root of 36, the only way I can get to 2 is by making it negative. So this ends up becoming 6 plus 8, which does not equal 2. So there is no solution on this. Okay? So make sure you check your answers for those extraneous solutions.